All right, let's talk humanoid robots. But forget the sci-fi demos for a minute. Today, we're diving deep into the business of it all. We're talking about commercialization, we're talking about mass production, and, how these things are actually going to become a real part of our economy. So, let's get into it.
So, first things first, let's just talk about the sheer scale of what we're looking at here. Goldman Sachs is forecasting the market for humanoid robots to hit, get this, $154 billion by 2035. I mean, that's just a staggering number. This isn't some niche tech experiment anymore, right? People are calling this the next huge industrial revolution. The money is very, very real, and believe me, the race is definitely on.
Okay, but 2035, that still feels kind of far away. A little abstract, doesn't it? So the real question, especially for anyone looking at this from a business angle, is when does this all actually start? When do we stop seeing cool prototypes and start seeing real production lines in actual sales? Well, the answer, pretty much across the board in the industry, is next year. 2025. That's what everyone's calling year one for mass production. This is the big shift, right? The conversation is changing from, hey, can we even make this thing work, to, okay, how do we build it cheap enough, reliably enough, and at a massive scale? And the big players, they're not hiding their plans. Tesla's talking about thousands of units. Figure AI is aiming for 12,000. And you've got Chinese companies like UBTech and Azubot also targeting thousands. The commercial era, it's officially here. All right, Section 1, the 2025 tipping point. Why now? So, why is this all happening right now? It feels so sudden, but it's really not random. It's more like a perfect storm, a convergence of these three really powerful forces that are finally making humanoid robots a viable business. Let's break them down. First up, you've got the AI revolution. This is a huge one. These new models, you might hear them called vision language action models. They're basically giving robots a brain that can actually see the world, understand commands, and learn new tasks on the fly. It's a game changer. Then there's labor pressure. I mean, all over the world, wages are going up, and it's getting harder and harder to find workers for certain jobs. That creates a massive economic reason for companies to look at automation. And finally, number 3, policy tailwinds. Governments, and you see this especially in China, are just pouring billions of dollars into robotics. They're setting up strategic funds and creating policies to push this forward, which creates this incredible feedback loop of policy and capital.
Okay, next section, anatomy of an intelligent robot. Brain versus body. To really get the business side of this, you gotta understand the product itself. And it's easiest to think about it in two parts. You have the brain, that's all the software and the AI, and then you have the body, which is the actual physical hardware that does the work.
Now this is fascinating. When you look at the cost breakdown, what we call the bill of materials, the brain, the AI, and the computer chips, that's only about 10% of the cost. The body, on the other hand, and specifically the parts that make it move, like the actuators and the hands, that's a whopping 50% of the total cost. So what does that tell you? The key takeaway here is that the real battle for profitability isn't just about writing smarter code. It's about mastering the hardware supply chain and figuring out how to make all those physical parts cheaper. And this table does a great job of laying out the whole competitive landscape. For the brain, you've got the usual suspects, right? Giants like OpenAI and Google building the big AI models, and of course, NVIDIA, which is providing the absolutely essential AI chips and simulation tools. But then you look at the body, and it's a different story. It's a mix. You've got some established industrial companies, but also this huge, fast-growing group of Chinese suppliers who are getting really, really good at making things like motors and actuators for less money.
All right, next up, the commercialization playbook. How will they actually make money? The tech is getting there, the supply chain is sorting itself out, so what's the actual plan to turn these incredible machines into cash flow?
So it looks like there are two main playbooks emerging. The first one is simple, direct sales. This is the old school way. You buy the robot, you own it. It's a big one-time capital expense, or what we call CapEx. But the second model, and this one could be a real game changer, is robotics as a service, or RaaS. Think of it like a subscription. You're not buying the robot, you're just paying a monthly or yearly fee to use it. It's an operating expense, or OpEx. And the big deal here is that it makes it so much easier for businesses to get started without a huge upfront investment.
And this is exactly why that RaaS model is so incredibly strategic.
It's not just about the monthly fee for the hardware. The real prize, the real value, is the data. Every single thing that robot does, every task it performs in the real world, that's data. And that data is pure gold. It's the fuel you use to train better, smarter AI. It creates this amazing feedback loop, what people in tech call a data flywheel. The more robots you have out there, the more data you collect, which makes your AI smarter, which makes your service even better and more attractive to new customers. It's a powerful cycle.
But wait a second. You might be thinking, why would a factory buy one of these complicated humanoids when they can just get a cheaper, proven robotic arm? And that is a great question. Here's the answer. The core value proposition. A traditional robot arm is fantastic at doing one single thing over and over with incredible precision. But you often have to redesign your entire factory line around it. That's super expensive and causes a lot of disruption. A humanoid robot's superpower is its flexibility. It's designed to walk into a space that was built for humans and just start working, which means you avoid all those massive hidden costs of re-engineering everything.
So, with that in mind, the first places we're going to see these robots pop up, the beachhead markets, if you will, are pretty obvious. Car manufacturing and logistics, warehouses. Why? Because these are environments that are already really structured. The tasks are repetitive, and it's super easy to calculate the return on investment. They are the perfect places to get these robots started, prove that they work, and start collecting all that valuable data before trying to tackle more complicated jobs. Okay, so this brings us to the big picture, the global robotics race. Who are the key players? Because this isn't just happening in one place. It is a massive, high-stakes competition between different companies with totally different strategies, and even between entire countries. So in the US corner, you have Tesla, and their strategy is classic Tesla, pure vertical integration. They're doing everything themselves. They're taking all the AI knowledge they built for self-driving cars and all the manufacturing know-how from building millions of EVs, and they're pouring it into their Optimus robot. The plan is simple but brilliant. Use their own factories as the first customer. They're going to deploy thousands of these robots to work on their own assembly lines. Essentially, they're becoming their own most demanding client to perfect the robot before they even think about selling it to anyone else. And then, taking a completely different path, you have Figure AI. Their approach is the exact opposite. It's all about partnerships. They're building a whole ecosystem. They went to OpenAI to get the best brain. They're using NVIDIA's chips for the computing power. And, this is the big one, they've already signed a deal with BMW to put their robots to work in a real car factory. So their strategy is basically, let's team up with the best in the world at each piece of the puzzle. Meanwhile, over in China, the landscape is just wild. It's hyper-competitive. You've got dozens of companies all trying to crack this market, and they're all doing it differently. You've got UbiTech, which is going deep on partnerships with automakers. You have Agibot, which is focused on building its own custom AI models from scratch. And then you've got this company called Unitree, and they're doing something that is making everyone else sit up and pay attention.
In this right here, this is the number that's sending shockwaves through the industry. 99,000 yuan. That's about 13,600 US dollars. That is the starting price for Unitree's G1 humanoid robot. Let me be clear, this is not just a price cut. This is a fundamental disruption of the entire market. For that price, you're putting a really capable humanoid robot into the hands of basically anyone, developers, researchers, small businesses. This can unleash a massive wave of innovation, completely from the bottom up. Okay, so let's start to bring this all together. The final frontier, the path to mass adoption. What does the road from these first few factories to, robots everywhere actually look like? Because let's be honest, the journey from the factory floor to your living room, that's still a pretty long road.
It really comes down to three huge hurdles that the industry has to clear. First, and it's always first, is cost. To really hit the mass market, they've got to get the price of a super capable robot under $20,000. Second is safety. This is non-negotiable. You have to be able to guarantee that these powerful machines can work safely and predictably around people, especially in messy, unstructured places like a home or an office. And finally, there's acceptance. We've got to figure out the social and ethical side of this. Are we ready for this? That's a huge question we'll have to answer. The vision for factories and warehouses is really clear, but the ultimate promise of this technology, the real endgame, is personal. So I want to leave you with a question to chew on. Think about it for a second. What is the one single task in your home that if a robot could just take care of it for you perfectly every single day, what's the one thing that would totally change your life? Because whatever you just thought of, that's where all of this is eventually heading. Thanks for tuning in.